Okay, so another graph of an exponential function. It says describe the domain and range. This one is a little difficult because of the 1/6, so we get some strange numbers. But easier than probably the one from yesterday because we don't have any sort of translations. We're not moving left or right at all, or up or down at all. So you should already know what your domain and range is going to be. Well, at least your domain, and your range won't be as difficult. We just need to decide if it's going to be flipped or not. And in this case it is. What makes it reflected? The negative, right. So we're going to start with the point that we know, which is the y-intercept. So what is the y-intercept? 0, -2. Perfect. Exactly right. So you want to start there. 0, -2. Now the issue is when you go down 1, you have to multiply -2 by 1/6. -2 times 1/6 is what? -1/3. -2 times 1/6. Just write it out if you're having trouble with that. It's -2 over 6, which reduces to -1/3. Yeah? And then you'd have to multiply that by 1/6, and you'd get, 1/6, and you get -1/18. Let's go backwards. Maybe we'll have some better numbers. So if we look at -1, what do we get when I plug in, or when I plug in -1, what do I get? So what I'm doing is I'm taking -2, again, write it out, divided by 1/6. What happens when I divide a fraction? Flips. So what that is -2 times 6, which is what? -12. Yeah, so a lot of this is just it's just testing you on can you divide and multiply by fractions, which some of you are having a little bit of trouble with. So either just do it by hand, plug in 1, plug in 2, plug in -1, or just write it out. Simply write out the division and remember to flip and multiply. And then if we get -2, what is our output? We go back one more. We're going to multiply that by 6. So what's -12 times 6? -72. Before I start graphing this, is there something on this T-chart that's not clicking or connecting with you? Is there something that you need me to re-explain? What do you think? Again, it's really just a matter of can you divide or multiply by fractions. And if you can, then you're good. So now we have some strange points to deal with, and I'm really just expecting you to sketch the graph, not really give me a super accurate picture. I just want to know that you know what the general shape is going to look like. So I'm going to go ahead and erase this. And you can really graph this however you want in terms of the scale. I'm just going to work with the points that we have and just graph a couple of them, because I should be able to get a general idea of how this graph is going to look, just based on a couple points. I don't even need to graph all of them. And in fact, I'm going to go by 2s. So I'm going to label a couple points here. You don't have to go by 2s, you can go by 10s, whatever, because this is going to go down very fast. So if you want -3, -4, -5, you'll have some huge numbers. So you might, I know in the book they did 550, didn't you? Okay, so I'm just graphing a few points on either side of my axis so that I know that my scale is by 2s here. So 0, -2 is going to be right here. 1, -1/3. So 1 would be halfway. So about here or so. 2, -1/18. I'm not going to graph that. -1, -12. something that looks like this. And I will have you write out the table so that I know you got those points correct. So in general, your graph should look like this. Does it look like that? Did it look like that? Okay, good. So what would your domain be? All real numbers, right. All real numbers. What's your range? Y is less than 0. Because you're going to go downwards. So your Y is getting, obviously, and we can see on the T-chart here, it's getting smaller and smaller at a huge rate, right? It goes from negative 1/18 to negative 12 to negative 72 to an even bigger or even smaller number, right? Okay, any questions on that? None? Okay. Well, I hope you feel more confident on these. All right, so we're looking at solving exponential equations with unlike bases. So the difference is that now we have bases that are obviously not the same. In order to approach, well, your approach to this should be the following. Look at 5 to the x, look at 125, and ask yourself, can I express 125, that base, can I make that base a 5? And you can. You have to just set up a factor tree. So in other words, take 125 and then divide that by 5. When you divide that by 5, you get 25, right? Remember these factor trees? Well, when you divide 25 by 5, you get 5 and 5. And this is actually broken down to a product of primes. You can always express bases as a product of primes and go that route. But we'll see in some examples we don't have to necessarily break it down to its primes. What's a prime number? A little bit more. Yeah, it's only divisible by itself and 1. Right. So in this case, 5 is only divisible by itself and 1. 5 is only divisible by itself and 1. 5 is only divisible by itself and 1. So it's a product of primes. Again, you may not need to go as far as breaking it down to a product of primes, but sometimes if you can't think of a number, just keep going and going and going to a product of primes for both of them, and you should end up with all 2s or all 3s or all 5s or all 7s, right? Does that make sense? So in this case, we have 5 to the third. It'll make more sense when I show you that example where you can break it down to a product of primes or not. So in this case, what I'm really looking at is 5 to the x equals 5 to the third. And our rule that we looked at yesterday said that the exponents are equal if and only if the bases are equal. Well, now the bases are equal, so what's the value of x? 3. 3. Does that make sense? Do you have any questions about that first one? Second one, we have to ask ourselves, can I express 2 in terms of, can I make a 2 a 4 or can I make a 4 a 2? Well, I can change the 4 and make it 2 squared, right? So that one was easy. We didn't even need a factor tree. So 2 squared, and you still have an x, equals 2 to the x minus 3. So all I did was I changed that 4 and I made it in terms of 2, base 2, so 2 squared. So now I have 2 like bases, and I can set their exponents equal. Well, this 2 is actually going to be distributed to anything that comes after it. So I just have an x after it, so really I'm just dealing with 2x. Does that make sense? Two gets distributed to the x, so I have 2x. I set that equal to x minus 3, and I solve for the value of x. Well, when I solve for x, subtract x, x equals negative 3. And you can always double check this by plugging in negative 3 for x. So you get 2 times negative 3, which is negative 6, so 2 to the negative 6. And you get that on the right side as well. Negative 3 minus 3 is also negative 6, right? Do you have any questions about that? Okay. Maybe not. So for C, we have a bit of a problem. What's the problem? Yes. Well, the bases aren't alike. The last one, we looked at only changing one side. So, yeah, we have unlike bases, but last time we only looked at changing one side, right? Well, if you look at 9 and 27, there's no way that you can express 27 in terms as a base 9, right? Because think about it, 9 to the first is 9. 9 squared is 81. I can't express that as 9 to some power, right? I can't express 27 as 9 to some power. So what I'm going to have to end up doing is breaking both of my bases down. So I'm going to look at 9 and I'm going to make a factor tree. Well, that's 3 and 3. So really I have to express 27 in terms of base 3. Does that make sense? Yes. Not 3 squared, well, 3 cubed, right? Because 27 is what? Just think of, you have 9 and 3, right? And that breaks down to 3 and 3. You have 1, 2, 3 threes, right? So that's 3 cubed. Does that make sense? So just think of something divisible by 27 and continue breaking it down. And again, we're dealing with a product of primes. 3's are prime, right? So what do I end up having? Well, I have a 3 squared, and then I have an x plus 2. Yeah. For 27, it's 3 cubed. So far, so good before we perform the distribution. Okay. Now keep in mind that you are distributing that 2 to each term. So what we really have now is 3 to the 2x plus 4 equals 3 to the 3x. Does that make sense? Do you have questions before we set the exponents equal? Okay, 2x plus 4 equals 3x, subtract 2x, subtract 2x. 4 plus x. X equals 4. Does that make sense? Well, 2 times 4 is 8, 8 plus 4 is 12, and then 3 times 4 is also 12. So in both cases, we're dealing with 3 to the 12. Does that not make sense to you? All I'm doing is plugging it back in, okay? Don't overcomplicate it. So I'm taking this and I'm plugging it back in here. So 2 times 4 is 8. 8 plus 4 is 12. So I have 3 to the 12. I'm just checking it. And then what's 3 times 4? 12. So aren't these equivalent? So I know that I did it correctly. This one? I took this 2 and I distributed it to each of these terms. Remember that we are distributing the exponent to whatever was originally in the problem. Yeah? Okay, we'll have one. Any other questions? That was a good one. Okay. All right, so we're going to look at solving exponential equations whenever your b value is in between 0 and 1. So in other words, we have a 1/2 now. The trick to these is to express a fraction in terms of a negative exponent. So what am I looking at? Well, I have 1 divided by 2 to the first power. How do I make this 2 to the first power? How do I bring it up? If I bring it to the numerator, what am I going to have to make the first power? Negative, right. So I have 2 to to the negative 1 times x equals 4. Well, from this point on, it's the same thing that we've been doing. Can I express 4, base 4, as base 2? And I can, 2 squared, right? So, I have 2 to the negative first power, x, equals 2 squared. Remember to distribute that negative 1 to the x. So you have negative x equals 2. So what's the value of x? Negative 2. Does that make sense what I did? Do you have any questions about that? Again, always turn your fractions into a negative exponent and then break it down either into a product of primes or into another base where on either side of the equation they're the same. First thing we want to do is express that fraction as a negative exponent. So I have 4, the x plus 1, and I'm going to set that equal to what? I have to express 1 over 64 as a negative exponent. Having a negative exponent first. 64 to the negative first, right? 64 to the negative first. Don't break it down quite yet. We'll get there. You have a couple choices. You can express 4 in terms of base 2, right? You could also express 64 in terms of base 2, and that, if you do it that way, that's when you break it down to the products of primes. But you don't have to. So the first thing I would suggest is always check and see if 64 is divisible by whatever's on the other side. So in this case, 4. Does that make sense? So I'm going to take 64. I'm going to divide that by 4, and I get what? 16, yep. And 16 is divisible by 4. Yeah, so 4 is not a prime, right? So I can leave it in terms of 4. Does that make sense? Or I could continue breaking this down to 2 and 2, 2 and 2, 2 and 2. And then that breaks that down to 2 squared. Does that make sense? Either one would work. I would go with the 4 because that's easier. So you have 4 to the x plus 1 is equal to 4 cubed to the negative 1. So you have x plus 1 is equal to negative 3. So x equals negative 4. I don't know, I like these. These are kind of fun. Do you have any questions? Yes. That's a period. I don't know why it's there. Yes. To not have a solution, that's a great question. Yes, you want to counter one though, because they're saying for yours, they want these to be equivalent. They want these to be equivalent. So for it not to have a solution, they couldn't even say that in the first place. Does that make sense? Great question. All right. The first question I have to ask myself before I start any of these is, can I express 256 in terms of base 4? And if the answer to that is yes, then we're on the right track. Okay? So I'm going to take 256, and I'm going to divide that by 4. Well, I get 4 and 64, and then I continue to ask myself, is 64 divisible by 4? And it is, yeah, so you can break that down into 16 and 4. Is 16 divisible by 4? Yes. 4 and 4. So, what I really have is 4 to the x is equal to 4 to the what power? 4. So x equals 4. Yeah? Next one. Can I express 9 in terms of base 3? Yes. So how would I rewrite 9 to the 2x? 3 squared times 2x, right? Equals 3 raised to the x minus 6. Remember that I'm distributing this 2 to the outside term. Well, 2 times 2 is 4. So I have 3 to the 4x equals x, or 3 to the x minus 6. Now some of you wanted to distribute that to the first 2 and get 4, and then add another 2 to an x. Don't do that. The only time that you have something where you distribute it to more than one term is if you have a plus or a minus, right? But we don't have a plus or minus here. So what we're setting equal is 4x equal to x minus 6. Subtract x on both sides. 3x equals negative 6. X equals negative 2. Did you get that? All right. Next one. We ask ourselves, can we express 8 in terms of base 4? No. We have 4 to the first, which is 4. 4 squared, which is 16. 4 cubed, which is 12. So that's not going to work, right? So I'm going to have to change both of my bases. Yeah? To what base? 2. Right, exactly. To base 2. So for number 6, so that's going to be 2 squared, and then I have the 3x on the outside. And then, how can I express 8 in terms of base 2? 2 to the what power? 2 to the what? Well, 2 squared is 4. 2 cubed. Okay, so in this case, I have 2 to the 6x. And now that's when you see how I have a plus here? I distribute that 3 to the x and to the 1. So I have 2 to the 3x plus 3. Now I can set those exponents equal to each other. 6x equals 3x plus 3. Subtract 3x from either side. You get 3x equals 3. X equals 1. Questions on that one? Good? All right, last one. The last one here. Okay, change your fraction to a base with a negative exponent. So what will I get when I change that to a base with a negative exponent? 3 to the negative first. X minus 1 on the outside equals 27. Now I see a minus sign there, so I'm going to take that negative 1 and distribute it to each of those terms. So I have 3 to the negative x plus 1 equals, how can I express 27 in terms of base 3? 3 cubed. So negative x plus 1 equals 3. Subtract 1 on both sides. Negative x equals 2. So x equals negative 2. Daniel, you seem puzzled. Are you?
Yeah.
Okay, which step?
The last step.
This one? Negative x equals 2? The whole thing step? Okay, so the very first thing I did was I said 1/3. I need to express that. I need to change that as a base raised to a negative exponent, right? Change your fractions to a base raised to a negative exponent. So 1/3 I changed to 3 to the negative 1. I keep that x minus 1 on the outside, right? I have 20 equals 27. Well, I have to express 27 in terms of base 3, right? So that's 3 cubed. So far we have this is equal to this. Well, I have a negative 1 and then I have an x minus 1 on the outside. You always distribute whatever's in parentheses to both terms on the outside if you're adding or subtracting. Right? So negative 1 times x is negative x. Negative 1 times negative 1, because we have a minus 1, is positive 1. Yeah? And so you have 3 to the negative x plus 1 equals 3 cubed. So now you have the same base, and our theorem that we talked about yesterday says that when you have the same base, the exponents are equal. So you take negative x plus 1 equal to 3, you make it equal to 3. You solve for the value of x, so you subtract 1 on either side. You have negative x equals 2, so x has to equal negative 2. Yeah? Okay. And again, just check it. Negative 2 times negative 1, if you plug it in for x, is 2. 2 plus 1 is 3. 3 cubed equals 3 cubed. All right, any other questions? Okay. Oh, if you have a graphing calculator and you want to work with some stuff on the graphing calculator to kind of help you, especially on the ACT and SAT, 328 has an example. We're not going to go over it. And here is your updated table of contents, number 15 being the new thing.